The National Electrical Code, or NEC, does not contain a specific rule that explicitly prohibits water lines from being installed inside a motor control center, or MCC. However, several general requirements within the NEC could be relevant to this situation and would need to be considered. Article 110.11 addresses the issue of environmental factors. This section states that electrical equipment must be free from recognized hazards that are likely to cause death, serious physical harm, or substantial property damage. The presence of water lines introduces a potential hazard that should be carefully evaluated. Any leaks or condensation from these lines could lead to corrosion, insulation breakdown, and ultimately electrical faults within the MCC. Article 404.10 focuses on the installation of motors and requires them to be installed in a location and in such a manner that will reduce the likelihood of accidental contact with water or other liquids in quantities sufficient to cause an electrical hazard. While this section directly addresses motors, the principle applies to other electrical equipment within the MCC. The key concern is preventing water from coming into contact with electrical components. Firstly, one must consider the potential for leaks or condensation from the water lines. Any fittings, valves, or connections within the MCC are potential sources of leaks. The water lines themselves could be susceptible to corrosion or damage, especially if they are not properly protected. Secondly, one must consider the materials used for the water lines. Metallic pipes could create a conductive path in the event of a leak, increasing the risk of electrical shock. Non-metallic pipes would mitigate this risk, but they must be suitable for the pressure and temperature of the water system. Thirdly, one must consider the location of the water lines within the MCC. If they are located directly above or near sensitive electrical components, the risk of damage from a leak is increased. It would be preferable to route the water lines along the sides or bottom of the MCC away from critical components. Fourthly, one must consider proper sealing and protection. If the water lines cannot be relocated outside the MCC, they must be adequately sealed and protected to prevent water from entering the enclosure. This may involve using waterproof fittings, applying sealant to connections, and providing a drip pan or other means of collecting any leaks. Fifthly, one must consider regular inspection and maintenance. Even with proper installation, water lines should be regularly inspected for leaks or signs of corrosion. A preventative maintenance program can help identify and address potential problems before they lead to electrical hazards. In summary, while the NEC does not explicitly forbid water lines in an MCC, it emphasizes the importance of protecting electrical equipment from hazards and preventing contact with liquids. The presence of water lines introduces a potential risk that must be carefully evaluated and mitigated. The best approach is to relocate the transducers and water lines outside the MCC if possible. If this is not feasible, then the water lines must be properly sealed, protected, and maintained to prevent water from entering the MCC and causing an electrical hazard. The authority having jurisdiction, or OJ, has the final say on whether or not an installation meets the requirements of the NEC and other applicable codes. They will consider the specific circumstances of the installation, including the type of water lines, their location within the MCC, and the measures taken to prevent leaks and protect electrical equipment. The AHJ may require additional safeguards or modifications to ensure that the installation is safe and compliant. To elaborate further, let's consider the practical implications of having water lines within an MCC and how to address potential concerns. When dealing with water lines inside an MCC, it's essential to thoroughly assess the specific application and the potential risks involved. This assessment should consider the following factors. 1. The type of fluid being conveyed. Is it potable water, processed water, or some other liquid? The properties of the fluid, such as its conductivity and chemical composition, can affect the potential for corrosion and electrical hazards. 2. The pressure and temperature of the fluid. High pressure or high temperature fluids can increase the risk of leaks and damage. The water lines and fittings must be rated for the maximum pressure and temperature they will experience. 3. The materials used for the water lines and fittings. As mentioned earlier, metallic pipes can create a conductive path in the event of a leak. Non-metallic pipes offer better electrical isolation, but must be compatible with the fluid and operating conditions. 4. The proximity of the water lines to electrical components. The closer the water lines are to sensitive equipment, the greater the risk of damage from a leak. The layout of the MCC should minimize the potential for water to come into contact with electrical components. 5. The presence of any vibration or movement. Vibration can loosen fittings and connections, increasing the risk of leaks. The water lines should be properly supported and secured to prevent excessive movement. 6. The accessibility for inspection and maintenance. The water lines should be easily accessible for regular inspection and maintenance. This may involve providing access panels or removable covers. After assessing these factors, you can implement appropriate measures to mitigate the risks. Here are some specific recommendations. Firstly, use non-metallic piping whenever possible. Non-metallic pipes, such as polyvinyl chloride or CPVC, offer excellent electrical isolation and are resistant to corrosion. They are a good choice for water lines within an MCC, especially if the fluid is compatible with the pipe material. Secondly, properly support and secure the water lines. Securely mount the water lines to the MCC structure to prevent vibration and movement. Use appropriate hangers, clamps, or supports that are designed for the pipe material and size. Thirdly, use sealed fittings and connections. Use fittings and connections that are specifically designed to prevent leaks. Apply sealant or thread tape to all threaded connections. Consider using compression fittings or other leak-proof connection methods. Fourthly, provide drip pans or other means of containment. Install drip pans or other containment devices beneath the water lines to collect any leaks. This will prevent water from spreading and coming into contact with electrical components. Fifthly, install moisture sensors or leak detectors. Install moisture sensors or leak detectors near the water lines to provide early warning of any leaks. These devices can be connected to an alarm system to alert personnel to the problem. Sixthly, provide adequate ventilation. Ensure that the MCC has adequate ventilation to prevent condensation. Moisture can accumulate inside the MCC, especially in humid environments. Ventilation will help to remove moisture and prevent corrosion. Seventhly, implement a regular inspection and maintenance program. Regularly inspect the water lines and fittings for leaks, corrosion, or damage. Tighten any loose connections and replace any damaged components. A preventative maintenance program will help to identify and address potential problems before they lead to electrical hazards. Additionally, it's essential to document all aspects of the installation, including the materials used, the layout of the water lines, and the measures taken to prevent leaks. This documentation will be helpful for future maintenance and troubleshooting. When selecting materials for the water lines, consider the following factors. 1. Chemical compatibility. The pipe material must be compatible with the fluid being conveyed. Some fluids can corrode or degrade certain pipe materials. 2. Temperature rating. The pipe material must be able to withstand the maximum temperature of the fluid. 3. Pressure rating. The pipe material must be able to withstand the maximum pressure of the fluid. 4. Electrical properties. Non-conductive materials are preferred to minimize the risk of electrical shock. 5. Code compliance. The pipe material must comply with all applicable codes and standards. When installing the water lines, pay close attention to the following details. 1. Proper support. The water lines must be properly supported to prevent sagging or movement. Use appropriate hangers, clamps, or supports that are designed for the pipe material and size. 2. Secure connections. All connections must be securely tightened to prevent leaks. Use appropriate fittings and sealant or thread tape. 3. Proper routing. The water line should be routed away from sensitive electrical components. Avoid running the water lines directly above or near these components. 4. Clear labeling. Clearly label the water lines to identify their purpose and the fluid they convey. This will help prevent accidental disconnection or damage. 5. Accessibility. The water line should be easily accessible for inspection and maintenance. Provide access panels or removable covers as needed. In addition to these recommendations, it's important to consult with a qualified engineer or electrician to ensure that the installation meets all applicable codes and standards. The AHJ should also be consulted to obtain their approval. They may have additional requirements or recommendations based on the specific circumstances of the installation. In some cases, the AHJ may require a complete separation of the water lines from the MCC. This could involve relocating the transducers to a separate enclosure or using a different type of pressure sensing system that does not require water lines inside the MCC. Ultimately, the decision of whether or not to allow water lines in the MCC is up to the AHJ. They will consider the specific installation and determine whether or not it meets the requirements of the NEC and other applicable codes. It is important to work closely with the AHJ to ensure that the installation is safe and compliant. The goal is to minimize the risk of electrical hazards and ensure the safety of personnel and equipment. By carefully assessing the risks and implementing appropriate measures, you can safely and effectively integrate water lines into an NCC when necessary. However, it's always preferable to relocate the water lines outside the MCC if possible, as this eliminates the potential for water-related hazards. Remember that safety should always be the top priority when working with electrical equipment. If you are unsure about any aspect of the installation, consult with a qualified professional.